So I'm going to open this up here in a minute. Make sure you are on the next page. Obviously you continue, next page, next page. You never ever see me continuing below another assignment. I've shared all that with you when I did your binders though. Okay. Commutative properties and associative properties. To briefly review, commutative properties can be used both with addition and multiplication. To commute literally means to move from place to place. Okay? Commute means to move. So people that commute to and from work are called commuters. They move from place to place. And what this is saying mathematically is in an addition problem, regardless of how I have the addition problem started, I can choose to move numbers around. This still is the same as this, even though I moved the 6 with the 2. Okay, you guys see how I moved there? So that's how it looks in addition. It might also simply be something like this. Something as simple as that. Both of these statements are still true, yes? All right. That's the commutative property of addition. In multiplication, it looks quite similar. I can say to you, 6 times 8 is the same thing as 8 times 6. And that is true. It's also true with more than that. 2 times 3 times 4 is the same thing as 3 times 4 times 2. All I did was move stuff. So commute moves things. Okay? And it's only done in addition and in multiplication. Okay? Commute means move. Associate. Associative properties. To associate is to group with. For example, I associate Jewel with Chris, Noah, Emma, Izza, and I could name everybody in this class, right? I am grouping her together with this class in my mind. In math, you can associate or group things together, but only in multiplication and addition as you like. Okay, you can only associate in addition and multiplication. Here's what I mean by that. 3 plus 4 plus 5. I can choose to group 3 and 4 prior to adding 3 plus 4 to 5. And I know you're thinking, well, you're already kind of doing that. And that is true. That is true. But by grouping, oftentimes I make things a little bit simpler for myself. Like here's an example. Some of your minds might do it automatically. 3 plus 7, so 3, 4, 5, 6, 7, 8, 9, 10, plus 6, 11, 12, 13, 14, 15, 16. By the way, I'm a finger user, I'm all for it. You may go that way, but if you see this, you might go 10 and 6. Done. With or without these parentheses. But these parentheses are what gives you the permission to group. Okay, when you use those, that's telling you you have chosen, or telling me you've chosen to group those items together. Okay? Multiplication works the same way. And maybe I will go, and again, it's used for ease. Right now, as it sits, you might say 30 times 6, but if you wanted to, you can say 3 times 20. Okay, you have that right to do that, and when you do that in multiplication, the answer will still be the same. Okay, so this is you grouping. Okay, grouping stuff together. Okay, with that said, we're going to go ahead and get rolling. Simply put, most of you are already doing this. You've just never named it before. We are going to go ahead and do the example 1 from the book only because I don't have another story problem that would be quick. So we're going to utilize the one in the book, okay, folks? Example 1, you buy a CD player for $48. You buy batteries, and those batteries are 25 bucks, and a CD case for 12. What is the total? Adding those all together will give you the total, right? So what is 48 plus 25? Most of you are going to grab your calculators, right? Not because you can't do it, but because it's quicker, right? What would be easier? Emma? Yes, move the 48 and the 12 so that they're neighbors. If you move the 48 and the 12 together, it's easier. I'm actually doing it a little bit differently than they are, but it still works. I have now moved these two. I maneuvered him over to here, okay? I can group and come up with 60. And in the end, come up with the same amount. They broke it down a little bit more slowly in the book, and by all means, you guys can chew on that at your leisure. What this does is it gives you permission to make an addition problem or a multiplication problem easier to do simply by reordering and regrouping stuff. Okay, it's very, very important that you recognize that you have the permission to do that. Evaluate. We're going to evaluate some stuff. Since the beginning of the year, you've been learning that when you are given the term evaluate, they'll usually say something like evaluate m equals 9 and p equals negative 12. Evaluate, and here's what I want you to evaluate. 5mp. By the way, when a number and letters are slammed together, what operation do you need to do? Yell it out. Woo, multiply. Okay, 5 times, what's the value of m, class? What's p, folks? Negative 12. Sure, 45 times 12, get your calculator out, the answer is negative. Or, we can do something a little bit different. We can find something that we can solve on our own. I can solve 5 times 12 on my own, in my head. Maybe you can't, but I bet you can. Did you come up with a negative 60 there? Okay. We still have to multiply that negative 60 by 9. You guys know what 6 times 9 is? So you guys know what 60 times 9 is then, don't you? I didn't touch my calculator, and I bet you I did it just as quickly as you would utilizing a calculator. Okay? You will not always have an electronic device available to you. Okay, so we moved, which if you remember was commute, right here. And I then grouped these together. Now the order of operations states that I would have done that anyway because those two are done first in order from left to right, but I just wanted you to visually see that. Okay? Let's do another one. Evaluate, and here's what I'm going to give you. X equals negative 6, Y equals 20. You're going to evaluate. Again, it's another one like example 2, and here it is. 5x squared y. Okay, x is negative 6. Y is 20. X is negative 6. Y is 20. The x is what gets squared, not the 5. The only time the entire thing would get squared is if there's a parentheses around it, and there isn't. So negative 6 squared is what, folks? What's negative 6 squared? Bravo. The value of y is 20. Can anybody see an opportunity here where you can move something and make it easier? Grace. She's right. Move that. Can you guys do 5 times 20 in your head? What is it? Can you guys multiply that by 36? Bravo. No calculator required. Okay? Keep that in mind. You are very, very much so capable of doing stuff without a calculator if you maneuver your numbers correctly. Example 3 says simplify. Remember, I'm giving you mine. The book has more. If you're confused, look at yours from your notes, watch the video, use the book as well. Simplify. 7 plus k plus 5. All right, folks, can we combine a number with a variable? No, they're not the same thing, right? If I have 2 peaches and 3 apples, yes, you can say 5 pieces of fruit, but that is now kind of confusing. I don't know what kind of fruit I have. But if I have 1 peach, 2 peaches, and 1 apple, you can combine the peaches, right? In this case, we have constants, and we have a variable. The constant 7, otherwise known as a normal number, and the constant 5 can be combined. Look at that. I just commuted my 5 next to my 7. What do you end up with? 12 plus k or k plus 12, right? Either way is acceptable. Combine like terms. Some of you don't even have to move it to make that happen, but if you need to, you have permission to because of the properties of math. 10b multiplied by 10. Last year, you may or may not have remembered this. You may or may not remember this. When you multiply and there's a variable involved, it's the numbers that get multiplied, and then the variable just shows up at the end. You know, it's like the person that shows up after the party's already been cleaned up. So the 10 is going to multiply with the 10. What's the answer to 10 times 10? Yep. 100b is the end result. Okay? 100b. Okay, example 3 has some more for you. Identity. So we've done commutative, associative, and now I'm going to give you identity properties. And these affect addition and multiplication again. Notice everything we're discussing is related to addition and multiplication. If you're not taking notes, you're going to have an issue. Got to be taking notes. Or maybe you copy them when you watch the video later. That's fine too. What if I say to you the identity property? What that means is adding, so this is the addition formula, 0 to a number equals the original number. Okay? 0 plus 12, what does that still equal? 12. Okay? In addition, 0 is what is called the additive identity. You won't use this very much, but you will need to know it. Okay, so this is the addition version of the identity properties. Multiplication. Multiplication. Multiplying a number by 1 equals the original number. Bet you guys thought I was going to say 0, and you guys were going to say, what? So 6 times 1 is still equal to 6, right? That is the rule for multiplication. You're already doing it. Therefore, 1 is it's not additive, it's multiplicative identity. Anybody's wrist sore yet? Mine is. Okay, what is the additive identity? Anybody know what number is the additive identity? Grace, go. 0. What is the multiplicative identity? Rachel, what is it? When you're asked, those are your answers. Okay, so far we've learned commuting, associating, and identity properties. Now, in example 4, they're going to give us some situations where they change something based on a rule. Your job is to tell me which rule I used. For example, 3a plus 0 equals 3A. What did I use? Commute, associate, or identity or something like that? Commute, associate, hope.
You did the identity.
Identity, good. Identity property of addition is exactly right. Again, those of you that are not getting complete notes, it's going to be on YouTube later anyway. I am able to do this and come up with this because the identity property of addition states that adding 0 to something doesn't change the original value. So 7 multiplied by the product of S and T is the same thing as multiplying 7 by S by T. Now, did I change the order of anything? 7ST. 7ST. So I didn't commute. If the order is the same, I didn't commute. That leaves me with identity or associative. Wow. Ellie, go.
Associative.
Now, is it of multiplication or addition? Well, what are we doing? Multiplying or adding? Good. Wonderful. Almost done.
Bring this number to the office, please.
A number multiplied by 1 is equal to the original number. What is it? Rachel, go. Good. Identity property of multiplication. And by the way, 1 is the multiplicative identity. Good job. Last but not least, don't let the fact that the parentheses have dropped. What has changed? Order, grouping, or did I multiply or add 0 or 1? What has changed? Order, go. Order, what's order? Good. Addition or multiplication? Fabulous. Guys, I'm sorry to ramrod through this. I hate to do this. Example 5. This is something called conversion factors, and you guys in the red book called it something different. I'm sorry, I can't remember what that was, but it's still the same thing. Okay. Here we go. This is going to go back to my running love. The Boston Marathon, or any other marathon, is 26.2 miles long. It's run every year on the third Sunday and Monday in April. How many feet is it? By the way, did you care when I run it or when it gets run? That's just extra stupid information that they're putting in there to confuse you. Okay, watch out for that. If something is 26.2 miles long and you want to know feet, you need to know the fact that there is that 1 mile is 5,280 feet, in the same way that this other factor, 5,280 feet, is equivalent to 1 mile. These two things are called conversion factors because they will be multiplied by the item you are converting. We are converting this to feet. Here's how you do it. Take the original item. Multiply it by the conversion factor with what you want on the top. In the end, what do we want on the top? Feet? Or do we want miles? Since our answer is looking for feet, it's what we want on the top. So which one will we choose? First one or second one? Second. Because you want to use the conversion factor with the new unit on top. So that would be 5280 over 1 mile. Okay? So the result is going to be the product. You guys already do this. You don't even realize it. 26.2 miles over 1 times 5280 feet over 1 mile. Miles cancels out. Any of you multiply that out, it's 138,336 feet. Otherwise known as 6 hours and 30 minutes of grueling moving forward.